All right, so guys, on Thursday when we last had class, you guys were asked to research the 5 different layers of the inside of the Earth, correct?
Yes.
All right, so I want you guys to help me out here. What is that inner layer called?
The core.
Which part of the core?
The inner core.
That's the inner core. So we have an inner core, which is considerably thicker than the outer core. Then we have the super thick region. That's called what?
Mantle.
Mantle.
I didn't know what it was called.
CJ.
Okay,
I
and
said
then,
M and I was right.
hey guys, then we also have this middle layer between the mantle and the outer shell. What is this middle stuff? It's spelled really weird.
See?
Oh.
Yeah, asthenosphere. Now the asthenosphere, guys, and this is kind of important that you guys recognize. Remember we talked about the fact that plate tectonics as a theory didn't really originate until the late 60s. We didn't even know that the asthenosphere existed until as well, so the late 1960s. And all of that comes from seismic data that we got. Now, do you guys actually know why we put seismic stations all around the world? To measure. Try again.
Because we felt like it.
No. Why do you think we have those all over the world?
To mess with our heads.
They were actually put there after World War II, during the Cold War. Because if you're testing atomic bombs, especially underground, it will register as an earthquake. So the whole point of the seismic station was actually to measure earthquakes that were created by seismic testing, and this way we could locate specifically where countries are doing their nuclear tests. A byproduct of that, though, is that we now use them to register seismic data. And through that, that's actually how we discover the asthenosphere. So it's kind of not really a new layer, but it's new to us understanding what it is. So it's kind of something new. And then the outer shell is called the what?
Crust.
Crust.
I've got a question. I don't know if you
Yes.
would know it, but like, how deep is each part? Like, how deep would the crust be?
Oh, that'd be a great question. That's what we're going to get ready to go into. So let's first talk about the inner core. All right, the inner core, again, we know this information from seismic data, but the inner core is basically solid. So it's completely solid inner core. Now guess how we know that? Because this will also be a homework question as well as a test question. How do we know that the inner core is completely solid?
It's really hot. And they can't. So
Yeah. Well, if it's really hot, it should be molten.
I know, but like I remember reading it. It's so hot that like they can't. They're just like combining together and they can't like move.
Yeah, it's such high pressure, right? It keeps it solid. But here's the thing: we actually don't know for sure if it's solid or not. There's no way to actually get down there and see. Well, what we can do is we can reason and look at other things around our world and see, okay, does that make sense? Well, take a meteorite. The meteorite literally is just the shell of rock. And it's got this little shell of rock, right? It comes crashing into our atmosphere. And then on the inside of that is its core. Well, what happens to all the outer rock as it comes crashing through our atmosphere? It burns away. So what you're left with is the meteorite, which is the core of the meteor. And in fact, that core is almost completely solid and full of iron. All right, and so that's how we kind of know that our inner core is solid. It basically comes out of meteorites. So Tanner, this answers your question. Basically, we're about 1,000 miles in radius. So basically, we look at that. That's really looking at kind of this line right here, about 1,000 miles. So if you want to think about the diameter, it's about 2,000 miles in diameter. As we said before, it's pretty much 80% iron, with the rest of it being nickel. Remember they talk about that in the videos from Thursday? The iron nickel core, 80 and 20. 8% iron, 20% nickel. And it's basically from here that we get all the heat that's released by the Earth. Okay, so tremendous amounts of heat coming from our core. So that's our inner core. Completely solid, iron and nickel. 80% iron, 20% nickel. The outer core, as we can see right here, okay, the outer core is basically molten metal. And so therefore, key difference between the outer core and inner core is the outer core is liquid, it's molten. But now the content doesn't change. We're still 80 and 20. We're still 80% iron, 20% nickel. So we're still basically have our same setup there. And then the thing that's really kind of important here to remember is, let me shrink this one down here. Is the rotation. That molten iron is actually rotating around the outer core or the inner core, and that rotation is what creates our magnetosphere. How many of you guys have ever seen the movie The Core?
Never heard of it.
Wow, never mind, wasting my time. All right, so let's move on from there. No, it's not even close to being scientifically accurate, but in the theory of it is that our inner core, or sorry, the outer core, stops rotating, and we lose our magnetosphere, and birds are flying into windows, and we lose all of our GPS units, and we're all dying. And so they had to create this machine that can actually withstand the tremendous amounts of pressure that are on the Earth, and then they release these nuclear blasts in the outer core that actually starts it to rotate again. Kind of a dumb premise, actually.
Who's in it?
Yes, but I can't remember. It's from like the late 90s. Came out right around the time of Armageddon and all that wonderful stuff.
So
Hillary Swank.
I'd like to want to be
Bruce Green.
It's so like that. Alright, so now let's talk about our mantle. What are some of the key characteristics you guys found out about the mantle?
It doesn't make spring.
Okay, I'd like to hear some ideas. Cool. Well, what did you learn about the mantle? Sure, tell me something you know about the mantle. Oh.
Good job, Cole.
Tanner, what do you know about the mantle?
I know that it is inside the Earth also.
Right? Wow. Alright, so basically the mantle makes up the majority of the Earth. It's 80% of all of Earth's volume. It's taken up by this tremendously thick chunk of the Earth. And now it is also completely molten, almost 2,000 miles thick. Now Earth only is 4,000 miles in radius. So when you think about it, so far what we have is the core and the mantle make up the 4,000 miles. And then we're left over with this really, really thin crust. I mean, you guys think like, man, it's so deep to go inside the crust. It's actually really thin compared to everything else inside the Earth. Okay, so when we're talking about thousands of miles with the mantle, the crust is only like 70 miles thick. So it's farther from here to Indy than the thickness of our crust. Let's do it that way.
We can dig.
What?
We're going to talk about that in a minute.
I heard that the deepest hole in the world doesn't even.
Sure.
We're going to talk about that. Now, folks, the mantle is a really important place because that's where we get a lot of the heat that drives plate tectonics. So a lot of the magma that wells up and creating convection currents, this is all taking place inside the mantle.
That's already.